Hello everyone, my name is Lý Jin Hong and welcome to my presentation. In my presentation, I will focus on AI for visually impairment. This is an outline in my paper. The first is introduction, second is the method, and the third is AI-based application in intelligence assistant device. And next a future research direction, and finally its conclusion. In the first paper is introduction about AI for visually impairments. In the first is visual impairment and its challenges. People with visual impairment face numerous challenges in their daily life, including difficulty traffic, accessing education, and receiving medical treatment. And the second is artificial intelligence to the rescue. AI is rapidly evolving and being implemented in various fields, including retail, logistics, education, and security. In the next is AI-powered solution for visual impairment. AI algorithms can analyze medical images of the eye, and AI Smart can help people with visual impairments navigate their surroundings by detecting obstacles and providing audio guidance. Finally is personalized learning and education. AI educational tools can adapt to the individual needs of visually impaired students, providing tailored learning experience. And move to the next paper is the method of AI for visually impairment. The integration of AI in medical imaging, especially for treating visual impairment, has garnered significant attention due to advancement in computer vision and deep learning. Utilizing CNN, GAN, and transfer learning technique has enhanced doctor accuracy and speed in clinical screening and prediction. And in this paper is the CNN method. In the picture show is the structure of a convolutional neural network. Convolution is described as a feature extraction process, with each convolution corner corresponding to one feature. Feature maps from one layer are convolved with multiple corners to produce new feature maps. The document provides a formula for the convolution operation and discusses the number of parameters and computation involved in a convolutional layer. It also mentioned the issue of output image size being slightly smaller than the input and the common solution of padding the image to address this problem. And in the second method is the GAN. And in this picture is illustrate the workflow of the GAN model, showcasing the interaction between the generator and discriminator in generating and discerning and real images. GAN consists of two main components: a generator that creates fake images and a discriminator that evaluates them. The generator uses noise to provide images from real datasets, while the discriminator learns between the generator facts and actual data. And we are moving to the third method is transfer learning. In this picture, show different learning processing between traditional machine learning and transfer learning. Transfer learning mimics human problem solving by applying knowledge to the new stack. It involves using the what learned from previous tasks to solve the new problems, much like how humans associate similar solved problems. This process enhances learning in a new domain for better solution, commonly seen in the computer vision, text classification, and more. Two main transfer learning methods are feature extraction and fine-tuning. Feature extraction utilizes learned representations to extract meaningful features, while fine-tuning adjusts the network layer for text-specific learning. And in the finally method is the combined multi-technology approach. Is CNN, GAN, and transfer learning all have their suitable domains. CNN perform much better in the supervised learning domain than in the unsupervised learning domain. Therefore, some scholars want to combine CNN with GAN. We call it the DCGAN, which performs well in the unsupervised learning domain. The introduction of CNN into the GAN method breaks the gap between supervised and unsupervised learning. Its strength relative to GAN is to use full convolution instead of full connection. The generator uses lacking ReLU and the discriminator uses ReLU. The generator and the discriminator use the batch normalization layers to ensure as stable training as possible. And in this paper, I will talk about AI-based application in intelligent assistive device. The first is assist in reading. Visually impaired people face significant challenges accessing information due to their limited vision and limited content and isn't available everywhere. Researchers are developing various assistive technology to bridge this gap. One study example is audiobook for learning in the blind school. Students appreciate the multiple reading voice and found them helpful. And another is the smart glasses with built-in camera that recognize text and generate speech. And the finally example is the smart glasses proposed in another paper can also read text and identify obstacles at night. This diversity in assistive technology demonstrates the ongoing effort to empower visually impaired individuals through technological advancement. And in the second AI-based application in intelligent assistive device is obstacle avoidance systems. In complex urban traffic conditions, blind people rely on traditional walking sticks to navigate and walk around, with the visually impaired touching the ground with the tip of the stick and exploring left and right to perceive objects on the route in front of them and obtain information about the road. But nowadays, the smart glasses use various computer vision techniques based on deep learning model regarding audio and graphics to recognize objects. To solve the problem that the traditional guiding devices are too large, the author proposed intelligent guiding device. The system can work as the guide and be used to in traffic light recognition, payment, and speech recognizing. It can effectively address the challenges in daily outdoor walking.
In the five part, we talk about future research direction. At the first, about vision care, it must be aware of the need to protect our eyesight as early as possible when we are young. It's the same like protecting children vision care in sports, visual health in aging populations, challenges faced by visually impaired individuals. And the next part about the government support. This part about technological advancements and thoughtful urban planning have significantly and enhanced the daily life of visual impaired individuals. Communication as indoor navigation solution, enhance cultural participation, improve public transport access, and urban accessibility. And the last, a future research direction about the smart home. We try to develop a smart home control method and access assistive technologies tailored for the visually impaired. It's something like smart home control method, challenges in assistive device, unmet needs, and future hopes. And the last, in the conclusion, it's about AI's based device has been developed to assist visually impaired individuals in reading, navigating street, and engaging in artistic activities. The future outlook embraces continuous improvement in computational technique and medical imaging quality, leading to enhanced algorithm and label datasets. And wearable devices, particularly for walking assistant, are likely to evolve and apply to more daily life situation. Uh, it's all of my present. Thank you for watching and listening. Thank you.